Some people have asked why I design products the way I do. Well, the fact is I design products for myself. To maintain that status that I have as an ex-wrestling captain, to be able to take them down. And you just can't do that unless you've got the energy and the stamina to go forward. What is a T cell? Well, a T cell is an immune cell. It's really the general that directs the rest of the immune army. But the T stands for thymus. In other words, these cells are trained in the thymus gland. When a T cell is first born, it's born as a very immature cell that's released from the bone marrow, travels through the bloodstream to the thymus, is then educated and differentiated, and at that point it should be able to read the transfer factor message and be able to then use the wisdom of generations instead of just its own wisdom. Transfer factor had originally been discovered in 1949 as an extract of white blood cells. My initial investigations into the immune system began in the mid-1980s when we were looking for ways to create a more effective vaccine for AIDS. Many of the things that we were using were not stimulating the immune system effectively, and so we looked at adjuvants that would be able to be added that would enhance the immune system response to the vaccines that we were then developing. I began with a group and looked at transfer factor and what that was. We are mammals, and our profile that our mothers provided us was much closer to the profile of another mammal, in this case the cow. So we use the cow as a surrogate mother because not only does she provide us transfer factor, but she provides us other components that are not species specific that can be used by humans and to great benefit. And so these are called the proline-rich polypeptides. When we looked at designing this new product, one of the things we asked ourselves is, when does transfer factor fail? The problem is that the thymus by nature is designed to develop until you reach puberty. Nature understood that we'd be staying in one place, and by the time we were 11 we should have known all the germs in our environment, and so that at that point she could shift her energy away from immune development and immune defense and understanding to reproduction. Well, the problem with that is that we travel. And so in order to work in an environment that's constantly changing, we need to have a thymus gland that functions. The aging of the immune system presages the aging of the rest of the body. If you keep your immune system young, the rest of the body will stay young. One of the most dramatic experiments that was done with that was in a case where the thymus of a young mouse was removed and surgically implanted in an old mouse. The effect was that the old mouse suddenly became much younger. And so we need to look at how to support that gland, how to allow ourselves the ability to produce competent T cells that can use the transfer factor message. And the best way that's been found to do that is to actually use thymus supplements. 12 years ago, when I began to work with transfer factor, we were able to design many products that were very beneficial. But in 10 or 12 years, science moves ahead in leaps and bounds. Taking that new knowledge and being able to then couple active components like the transfer factors, the proline-rich polypeptides, the phytoplanktons, we were able to create a system of supplementation that allows us to support all the primary functions of the body, the ability to maintain an effective antioxidant shield, the immune system, and also the efficiency of our metabolism.